we can compute higher order derivatives using implicit differentiation. Just keep taking derivatives. So I've got some equation right here, some relationship between x and y, some constraint, so that given an x, you get a y, or possibly multiple y's, probably multiple because it's quadratic. And we want to shoot for computing the second derivative of this curve at some specific point. The process is going to be completed by doing 2 steps of implicit differentiation. So let's start by taking a derivative of this thing. We're going to take derivatives of both sides. So that implies that x times 2y times y prime plus y prime minus derivative of 2 is 0 equals derivative of 0, 0. Sweetness. I need to isolate y prime. So I'm going to factor out a y prime from this expression. So that's going to be 2xy plus 1 is equal to 0. Nope, I messed up. Hey, check out my mistake that I made. It's getting late in the day and I'm ready for dinner. I was like, but now I'm going to have to divide by this and I'm going to get just 0. But that's clearly a lie because, like, my work right now shows, like, y prime equals 0. But, like, there's no way that this is true because otherwise y would be constant. And clearly y is not constant because it depends on x. So this is erroneous. I made a mistake and that's just fine, but I caught it. So let's back up. What did I do wrong when I computed this derivative? Let's see here. Oh, I forgot to take the derivative of this using the product rule. Okay, so let's wipe and start over. Just like an instance in World of Warcraft, sometimes you just gotta wipe and start over, and there ain't nothing wrong with that. Okay, so let's take the derivative. Derivative of the right-hand side is still going to be 0. Derivative of 2 is still going to be 0. That's still going to be y prime. So let's product this. So let's go. The derivative of the first is 1 times the second y squared plus the first times the derivative of the second, 2y y prime plus y prime equals 0. I'm going to omit that 1 times because it's not doing me any favors. Alrighty, so let's put that y squared on the other side. And let's factor out our y prime. 2xy plus 1 equals minus y squared. And finally, that means that y prime is equal to minus y squared over 2xy plus 1. I don't know why I wrote parentheses down there. They don't help anything. I'm going to delete those. Sweet. So we got our first derivative, and we can take second derivatives. So I still have this relationship between y prime and y and x. When you take derivatives of first derivatives, you get second derivatives. So this implies that y double prime is equal to, let's use the quotient rule. All right, so I'm going to go low. 2xy plus 1. D high is minus 2y y prime. Make sure you have those primes as like little slanty dealies so you don't just think they're to the power of 1. This is an awful y, so let me try it over again. There we go. Okay, so that's derivative of the first. So so we went low d high. Okay, low d high minus high d low. So now I've got to do a product rule on that 2xy again. So let's see here. So 2xy prime. I'm going to spill off the screen here. Plus 2y. Oh, I made it. Okay. Yeah. Because the derivative of 1 is 0. Okay. So let me check my work. Okay, so low, d high. There's the minus 2. The 2 came down front. I have a y. I have to chain out a y prime because y depends on x. we're not done. We're not taking the derivative of y squared with respect to y. We're taking the derivative of y squared with respect to x. So that's why it has to chain out. So that's low d high minus. This is a minus minus in case you didn't pick that up. It's a minus minus, which is just plus. So minus high d low, invoking the product rule on this thing right here. So I've got a 2 in both those terms. X, y prime, and then the derivative of x is 1. So I just pick up that. Okay, great. Draw a line and square below. I'm going to put these double negatives back to a positive. What other simplifications can I make? I think that's about it. I could like start pulling some 2's out and stuff like that. I'm not sure that's going to help me do anything. Alrighty. So I've got this expression for y double prime. And I want to evaluate this thing at 1, 1. So I have my x and my y values, right? That's x and y. X is 1, y is 1. Okay, cool. So that takes care of all of these things, except that I need the value of y prime also. So we need y prime at 1, 1 in order to plug it in for this thing right here, this y prime. It appears there also. So let's just plug in. So I'm going to have minus 1 over... Okay, so that's minus a third. Because in the denominator I have 2 plus 1. I'm glad I was given 1, 1 because that will simplify things a lot. So that's going to go in right here and right there. And everywhere else I'm going to put 1s because I'm lucky enough to have been given the point 1, 1. Whoever wrote this problem was generous. One thing we didn't do was check and see that 1, 1 is actually on this curve, but it is because 1 plus 1 minus 2 is 0. Alrighty, so y double prime evaluated at 1, 1 as an ordered pair is equal to, I'm just going to have to write this down super step by step. Fortunately, everything's just 1 except for that y prime, so I've got 2 plus 1 times minus 2 times a third with a minus sign on it. It's going to cancel that one. Plus 1 times 2 times minus a third plus 2 times... nope. That's just 1. There we go. All over 9. Let's boil this down to a number. Get rid of that. Let's emphasize. Simplify. That's 2 times a third. So multiplying by 1. This is plus 2 right here. So this is minus 2/3 right here. Boop, 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 boop. 2 plus 1 is 3. Oh, 3 cancels with a third back there in that multiplication. So that's nice. So that's going to go. I don't need those parens anymore. Negative 2/3 plus 2 is 4/3. And then 2 is the same as 6/3. 6/3 plus 4/3 is definitely 10/3. Is going to be 10 over 27. That wasn't so bad. I think the trick to pay attention to when doing a problem like this is making sure that you're always doing like the quotient rule or the product rule, because it's really easy to forget that because I have two different looking symbols right here. So it's really easy to forget that y depends on x. So it can be useful when you start out one of these problems to be like, yeah, that marker sucks. To be like, yeah, y is equal to y of x. To just remind yourself, like, hey, like, y depends on x. And this furthermore will remind you when you take derivatives of expressions involving y's, they have to chain out a multiplicative factor of y prime, right? When I took the derivative of the 2y, of this y squared, I get 2y y prime. That y turned into y prime. When I took the derivative of this 2xy, it turned into this thing right here, this 2xy prime plus 2y, because of the product rule, and then the derivative of y with respect to x is y prime dy dx. And I think the other tricky thing maybe is being sure that you have things evaluated at the right places and stuff like that. I don't know how you can check your work on this terribly easy. It's kind of challenging to check your work. But that's implicit differentiation for finding second derivatives. Thanks for watching. I hope you have a lovely one. Bye.